All right, and here we are. We're going to move on to example 4. Oh, I think I need to switch the pages out there. There we go. Do that quickly. And like I said, we're in example 4. In example 4, we're solving an equation with radicals as well. But this time we have 2 radicals. So solving an equation that has 2 radicals. All right, and so we have basically a direction that says solve, and then they give us the square root of 3x plus 1 minus the square root of x plus 4, and this is equal to 1. And so step 1, again, is always to isolate the radicals. And so the idea is they're not isolated if they're both on the left-hand side. So what we're going to do is we're going to add the square root of x plus 4 to both sides. What this gives us, or leaves us with, is now one radical on the left-hand side, and there is technically another radical over here on the right-hand side. And the only difference is this is attached to a 1. So there's like a plus 1 scenario. Now these are both raised to the 1/2 power. So to undo it, we raise it to the 2nd power. It's basically the reciprocal. Notice that I'm grabbing all of the right-hand side. In other words, it's not just a radical that's getting squared. It's the plus 1 that's included there. So what happens on this side, on the left-hand side, is you're simply left with the 3x plus 1. And on the left-hand side, we're foiling the square root of x plus 4 plus 1 times the square root of x plus 4 plus 1. Okay, so I'm going to show you step by step so you see the connection here. So the first terms, obviously, we are left with 3x plus 1 on the left-hand side, and these 2 first terms multiplied against each other leave us with just simply x plus 4. The inner outer terms, this is 1 times the square root of x plus 4 plus 1 times the square root of x plus 4, so we have plus 2 radical x plus 4. And the last terms, 1 times 1, we obviously are left with plus 1. What we want to do at this stage, and if you just take a moment, take it in, notice that this term can be added to this term. And so I can start to simplify this to get 3x plus 1 equal to x plus 5. And then obviously plus 2 square root of x plus 4. I'm now going to subtract the x and subtract the 5. I'm going to subtract that x and I'm going to subtract that 5 on both sides, just like that. And now I'm left with simply 2x minus 4 equal to 2 square root x plus 4. Remember, these guys over here are canceling out, respectively. I still have a radical on the right-hand side, so guess what I'm going to do now? We're going to take both sides, because remember, if I'm squaring to get rid of that radical on the right-hand side, on the left-hand side, I have to repeat the same. When I do this, I get 4x squared minus 16x plus 16, and this is equal to 4 times x plus 4. Because remember, this 2 gets squared. 2 squared is 4. And when I square the radical x plus 4, I'm just left with x plus 4. And now I just need to distribute it. So I have 4x squared minus 16x plus 16. This is equal to 4x plus 16. Now remember, we want to combine like terms and make one side 0. So I'm going to subtract the 4x and subtract 16. Again, I'm going to subtract the 4x and subtract 16. Notice what happens at this step. Basically, I'm left with 4x squared minus 20x The 16s cancel, and this is obviously equal to 0 because both of those canceled out. And now what I want to do is consider how I can factor this further. So if I go ahead and extract the common term, so 4 goes into 4, 4 goes into negative 20. So I'm definitely taking out at least a 4 and at least an x to the first power. This leaves me with x minus 5 equal to 0. Remember, the idea is once I start dividing by the 4x, I'm dividing it here and here. So that if I reverse the process, I actually will end up right back to where I started, right? That means that I have 4x equal to 0, and I have x minus 5 equal to 0. So therefore, x is equal to 0, or x is equal to 5. Now, we have a radical. So what we want to do is we want to test it by putting it back into the original equation. And so I'm going to take the square root of 3x plus 1 minus the square root of x plus 4, and this is supposedly equal to 1, and we'll test the 0 and the 5. So square root of 3 times 0 plus 1 minus the square root of 0 plus 4 equal to 1. So this is going to end up giving us 1 minus 2 equal to 1, which leaves negative 1 equal to 1, and that is not true. So this is a false answer. So what we want to do then is apply the same process to the 5. So if we take the square root of 3 times 5 plus 1 minus the square root of 5 plus 4, we should have a value of 1. This is 16. 3 times 5 plus 1 is square root of 16 minus square root of 9 equal to 1. Obviously this is 4 minus 3, and that is equal to 1 because 1 is equal to 1. This is a true statement, and we accept this as our answer. That means that my only solution is the 5 in this case. All right, so here's what I want you to do. I'm going to take a minute, as we always do, and we're going to try one ourselves, following all the steps that we've taken here. So I'm just going to write down the try question. So the question is simply to solve the square root of x plus 5 minus the square root of x minus 3 and prove to me that that is equal to 2. I'll give you a minute to pause the video, try to work it out. Your solution for this question should only be this answer, which is 4. Okay, go ahead and try that, and let's see how we do. I'm going to move on to example 5 here. In example 5, we are solving equations involving rational exponents. Now, this may look ominous, but I promise you, follow the example I give you and it will stick like glue. And we will practice this. So I'll start with example A. There is an example B, so I'm going to do A first. They start us with 3x raised to the 3 over 4 power, minus 6 equal to 0. So if you'll notice, my first step in red is going to be to add the 6 to both sides. And this leaves me with 3x raised to the 3/4 power is equal to 6. Now remember, you're solving for x, so I'm going to have to divide this side by 3 and this side by 3 as well, canceling this out, leaving me x to the 3 over 4 is equal to 3. And now, I'm sorry, not 3, but 2. I can add, or divide, sorry. Now, if you notice this is raised to the 3 over 4, we're going to raise it again by its reciprocal, which is 4/3, and we're going to do the same thing over here, 4/3. Now, what I want you to remember is that we already have the answer where x is equal to 2 raised to the 4/3, which, by the way, the cube is always a root. What's inside of here is 2 to the 4th power, and it's always written in that form. Using a calculator, I can estimate that this is going to be 2.52 as a value. So your solution set is right here. Now we always check it. You know how to check it is simply plug it back in. So we begin with our question where we have 3x raised to the 3/4 minus 6 should be equal to 0. And in our example, this 3 is multiplied by 2 to the 4/3. All right, and remember this is raised to the 3/4 minus 6 is equal to 0. Well, remember, what's happening here is that 4 times 3 is 12 and 3 times 4 is 12, so this zaps itself out. And you're left with 2 times 3, which is 6, minus 6, which happens to be 0. That's how we know that we have the right answer. Okay, that's example A. Let me do example B. More of the same. We have x raised to the 2/3 minus 3/4, and this is equal to negative 1/2. Now, keep in mind, whenever we add or subtract fractions, we always need a common denominator. And so the first thing you're going to do is you're going to add that 3/4 to both sides of this equation. In addition to that, you have to change this by multiplying by 2 top and bottom and renaming this negative 2/4. So you're really adding 3/4 and negative 2/4. If you look at the big picture, remember these guys canceled. So now what you're left with is x to the 2/3 is equal to basically 1/4. Now, to get rid of that 2/3 and release the x, you're going to multiply, or not multiply, you're going to raise it to its reciprocal, hence 3/2 on both sides. So this all cancels, right? Because that becomes 6/6, which is 1, leaving you just the x, and this is equal to basically plus or minus 1/8. Remember, you're taking the square root of 4, actually square root of 1/4, right? Which is going to give you square root of, not square root, it's going to give you 1/2, and 1/2 is then raised to the 3rd power. So the square root, or the root goes first, then you raise it to the power. Whenever you see a variable, it's always the power over the root, and the root comes first. Just for the sake of an example, let's do another one real quick. Say I'm looking at, let's say I'm looking at 1/16. And that is raised to the 3/2. So the step 1 is I'm really looking at the square root of 1/16. And then after I take that, I'm going to raise that to the 3rd power. So this becomes 1/4 on all of that to the 3rd power. So this will be 1/64 as an answer. That's what this actually represents. All right, if you need help with any of this, we can always discuss it in class. And what I'd like to do next is give you 2 questions to try. I'm going to pause the video. So let me give you question C, which is just like question A. So you have 5x to the 3/2 minus 25 equals 0. So go ahead and work that one out. After that, we're then going to do part D, and I'm going to give you x raised to the 2/3 minus 8 equal to 4. equal to negative 4. Go ahead and try those two questions, and I will give you the solutions in 1 second. So I'll go ahead and pause that video for you. So as you can see, the solution for C is either 5 to the raised to the 2/3, or we can look at it as the cube root of 25. And when you look at the solution for D, this should be either plus or minus 8. Okay, and usually in the Pearson program, they like you to use -8, comma, +8. All right. Last example for this section will be number 6. So this will be example 6. So this one basically is solving an equation in quadratic, or they say in quadratic in form. I don't know why they say it that way, but they do. All right, here we go. Quadratic in form. So what I want to do is show you this question 2 ways. So they start you with giving you the question where it says solve x to the 4th power minus 8x to the 2nd power minus 9 equal to 0. That's your question. They do want you to use what's called U substitution, and this is something that you are going to definitely have to master in calculus and pre-calculus. We do use U substitution from time to time. Sorry, sloppy writing. Substitution. Wow, I'm having a spelling moment. Okay, there we go, much better. So what is U substitution? So let me show you that quickly. You see here how I'm highlighting the x squared, and that's the center term. Given that this is in highest order to lowest order, that tells you right away that your U value is going to be equal to that variable and that power, and that in our case x squared. And so I'm going to replace this here. Since I know that this is x squared squared, this is really saying U squared minus 8U minus 9 equal to 0. Okay, so that's one way you are going to approach these questions. And when you do examples 7 and 8, you're going to notice that you're going to need to use U substitution. Now, the reason we use U substitution, and I'll keep reminding you of this, is because this is very easy to factor now. This is simply going to become U minus 9 times U plus 1. And now we can solve where U is equal to 9 or U is equal to -1. And we bring back our substitution, right? So we're going to now take that x squared and throw it back in. So what we have here is really x squared is equal to 9. And we have x squared is equal to -1. So if I take the square root of both sides on this side, I end up with x is equal to plus or minus 3. And if I do the same here and take the square root of both sides, I get x is equal to, in this case, plus or minus I. So remember, hopefully you do remember, that I is equal to the square root of -1. And one of the little gimmicks that you're going to have to learn in this lesson is the 4 powers of I. The I squared, the I cubed, and the I to the 4th. Okay, and I'm going to have you learn these by heart. So think about it. If this is I squared, this is square root of -1 times square root of -1, which is equal to -1. If this is I cubed, we already know that this is square root of -1 times I squared, which is negative 1. So this is really the negative I, or you can call it the negative of square root of negative 1. And I to the fourth is simply just 1, because it's basically I squared times I squared, which is 1. These 4 powers of I are extremely important, because I know for a fact one of the SAT questions you're going to run into is they're going to ask you to evaluate something like I to the 76th power. And you won't have a calculator. This is no calculator. So then how do you do that? And so the easiest way I can explain this, and I'll actually use a smaller number. Let's do I to the 6th power, for example. If I do I to the 6th power, I want you to count how many times 4 goes into 6 and how many is left over. So it goes in 1, 2, 3, 4. Notice I'm double checking here and finishing at I6. So I to the 6th power is equivalent to negative 1. If they give me another value, say they give me a value, say a little bit bigger, say I to the 17th. Again, how many times does 4, or how many times can I divide 4 into 17? It goes in 4 times evenly, 1, 2, 3, 4, but I'm left with square root negative 1. Okay, so you can go ahead and play with your calculator, and I'll do a couple others. And same thing goes for the 76. I would divide it by 4. 4 goes into 76. It definitely goes in 1 time with a remainder of 3. And 4 goes into 36 9 times. So if I count this 19, this would be a 16th, 17, 18, 19. That would be your answer. So this would be square root of negative 1, or negative I. Cool, huh? If you want to talk about this some more, we can. All right, I'd like for you to try this next one. This is your try question, where I have x to the 4th power minus 5x squared plus 6 equal to 0. Okay, I'll pause the video and give you a few seconds to try this in class. And once we go over it, then we'll do example 7 and 8, and we'll be done with 1.6. So the solution for number 6 are plus and minus radical 3 and plus and minus radical 2. And there you have it. That's the notes for the examples 4, 5, and 6. 7 and 8 are coming up.